Hiya guys, BuildZoid here, and today we're going to be taking a look at the ASUS Prime X470-Pro motherboard. Big thanks to all the patrons and people who support AHOC through PayPal, as well as buying shirts and everything else down by the link in the description below. Because without you, we wouldn't be doing this video. So yeah, this is the board. It goes for about $180 in America. I got the board for 150 quid. And it's, before we get to the VRMs, I'm just going to point out that I'm already, ignoring the VRM, I'm already incredibly disappointed by this motherboard. And there's a very simple reason for that. There is no troubleshooting LEDs, there is no postcode, there is nothing. There is literally nothing in as far as, making, quality of life when overclocking is just not addressed at all with this board. There's nothing. And I find that extremely, disappointing, because this board's $180, and postcodes and LEDs don't cost that much. And this board is pretty damn expensive. It should have those. They're not, the board we looked at before, the MSI X470 Gaming Plus, that has 4 debug LEDs for troubleshooting system boot issues. Actually, I think most of the other board vendors have boards that are way, way, way cheaper than this thing that have troubleshooting LEDs, at the very least. And then there's some boards that even have postcodes that are around the same price as this, I think, if my memory serves me correctly. So this having absolutely freaking nothing as far as troubleshooting boot issues go is extremely disappointing. The other thing is there's also no dual BIOS, and I've not been able to find a clock gen either. Though I will check if the BIOS, maybe the BIOS actually has BCLK overclocking and I'm just blind and I haven't found the chip. But as far as I can tell right now, there's no clock gen, and there's also no dual BIOS. So as far as sort of the important overclocking features go, this board is just extremely disappointing, and we are not even talking about, I'm that's just, yeah. Very, very disappointed in that. It's just freaking, put 4 LEDs on the edge of the board. And the funny thing is, ASUS in the past would actually put, on their, not top of the line, on their cheaper mainline boards, not the ROG stuff. So basically what this Prime lineup is, so boards that used to be in the equivalent of this in the past, they would have a LED by the CPU socket to indicate if the CPU is working or not, an LED by the BIOS chip to indicate if the boot media is working or not, an LED by the RAM to indicate if the RAM is working or not. And it's just there's nothing. There's absolutely bloody nothing on this board in terms of troubleshooting. So I am that is just very, very, very disappointing. It's just, yeah. Anyway, let's get on to the VRM, because that's significantly better. And yeah, this photo sucks. I'm aware of it. I couldn't be bothered to pull out the DSLR for this, so whatever. The VCore VRM is this block right here, so that's that. The SoC VRM is this block right there. So that's your SoC. Both are controlled by this chip right here, which is an ASP 1405. So this is the high-end Digi Plus voltage controller for ASUS. They use this on a lot of boards. Here it is running, I think the Crosshair 6 and 7 use the same chip. I just can't remember exactly right now. I was kind of interested in getting this video done quick. So yeah, it's running in a 6+2 phase configuration. There are international rectifier 3599s used for doubling up the +2 part. So that +2 gets a nice little ×2, like that. So essentially you have a 6+4 phase VRM, which we'll get to that. So yeah, 6 is for your VCore, the +4 is for your SoC. So that's that. The IR3599s are those chips right there. These are really dumb doublers. So basically you put a PWM signal into them. They can also quadruple. You push a PWM signal into them, and they basically split the signal between 2 or 4 phases. In the process, they cut the switching frequency of that PWM signal in half. So basically, like if you're using these, you might want to compensate for the dropped switching frequency with a higher switching VRM switching frequency, which you should be able to control because this chip will, like ASUS BIOS should have switching frequency controls for the ASP1405 in the Digi Plus menu, but we'll go into more details on that when I actually do the BIOS overview for this board. So yeah, but the SoC VRM is like I would consider this is closer to being a 4-phase than it is to being a 2-phase. So this is definitely better than if you compared it to like a 4+2 phase board or a 6+2, or like your SoC is not a +2. I'd say it's around the same level as like a +3 or it might even be able to keep up with a proper +4. But I don't think there's any boards that actually have a 4-phase SoC VRM without a doubling scheme. So yeah, but basically the SoC VRM here has a lot of phases compared to a lot of other boards. The V-Core is the 6-phase, and both of the VRMs use the same power stage. So this chip right here, which you can see is you have 6 of, and actually I'll take this one because then I can pull the line properly. That's an International Rectifier 3553. If you follow this channel, you should be very familiar with what this is. This is a 40 amp International Rectifier power IR stage. So International Rectifier has IR part numbers. And there's 6 in the V-Core, there's 4 in the SoC. That's how many phases you have, so no surprises there. And the end result of using these is that this V-Core VRM is capable of pushing for 1.4 volts, which is well, let's try this. I'm trying to minimize how much writing I have to do, and I'm kind of not working that out, am I? Oh, whatever. 1.4 volts and 75 amps, which would be like a 1st gen or a 2nd gen 6-core, but the 6-core would actually be on less voltage. The 2nd generation Ryzen chips actually pull a bit more current than the 1st gen Ryzen chips for a given voltage, which makes sense because they clock higher. So if you do more clock cycles, you do more work, you burn more energy. Rather simple, especially if your voltage hasn't changed. So yeah, 75 amps, 100 amps, which would be like an 8-core 1st gen, or 125 amps, which would be a 2nd gen 8-core being absolutely like hammered at 1.4 volts. So across this current range for 75 amps, and I forgot to mention that the VRM would be running at 400 kilohertz switching frequency, which I think ASUS might be running it quite a bit lower, though there's not really any good reason to, because the efficiency gain from going from 400 kilohertz to like 200 kilohertz on the 3553 is like nothing. It's like you might you might lower power loss by like 5. Actually, that's a pretty decent amount, isn't it? 5% out of 12 watts. That's nothing, actually. Yeah, it's like a few fractions of a watt you would save if you go from 400 kilohertz to 200 kilohertz. So I'm rating the VRM at 400 kilohertz. This is a high switching frequency for a X470 VRM. I don't think there's a lot of like, well, for example, you know what? I don't know where I was going with that now that I think about it. I should slow down when making these videos. Oh no, yeah, this is the point I wanted to make. So this probably, like, I'm doing the rating for this VRM at 400 kilohertz. When I did the MSI X470 Gaming Plus, I did that one at 300 kilohertz. And the end result is that the MSI board actually looks like it can keep up with this VRM in terms of efficiency. But the MSI, like the main problem with the MSI board, which I mentioned in the previous video, is I don't actually know what switching frequency it's like normally runs at, because it's dynamic. And if that board does what I think it does, which is change the, like, go higher switching frequency under load, which it probably does, and I'll verify that, and then I'll probably have to change that video to match the fact that if you push a lot of current through that VRM, it actually gets less efficient because it'll try to maintain ripple. But if that VRM goes into like from 300 kilohertz to 400 kilohertz, it ends up like a lot less efficient than this one right here. Even though right now, like the power heat output figures I'm going to write down are going to look pretty close for both of them. Anyway, let's get to those powered numbers. 75 amps, you're going to be looking at about 8 watts of heat output, which is fine. The 100 amps, you're going to be looking at about 12.5 watts of heat output, which is actually like exactly the same figure as what I had for the MSI board, which is why I'm pointing out, why I'm pointing out 300 kilohertz versus 400 kilohertz disparity. If the MSI board was at 400 kilohertz, it would be a lot, like a couple of watts hotter than 12.5 watts. So yeah, and I might have to actually revise that video once I get a measurement for how high switching frequency that VRM runs. YouTube doesn't really give you a good way to do that, do they? No, they don't. Oh well, whatever. We'll figure something out. And then for 125 amps, this board would produce about 16.5 watts of heat, where it actually, like, this is better than the MSI board. Even with the MSI board at 300 kilohertz, that one produced about 18.5 watts for 125 amps. So this right here is, this is a couple watts more efficient, and that's at a higher switching frequency. And the reason why you want a higher switching frequency is it gives the VRM a faster response to current draw changes and better voltage regulation. So, yeah, basically this VRM should overclock better because it also has more true phases than the MSI board. So even if thermally it looks very similar, this one might be able to push the same clock at a lower voltage than what the MSI board does, and I'll actually have to test that. But yeah, that's just that's the heat output figures. Now, what isn't good on this board is this heatsink. Okay, this heatsink, I posted a picture of the heatsinks in the community tab of the YouTube channel. Basically, like, if you look at pictures of the board online, it looks like a big, heavy aluminum block. In reality, it's a extruded section that basically looks like this. It has no, and your MOSFETs would be down here, right? So MOS. And it's just, and it's kind of like, it has a bit of a curve to the top, and that's your VRM heatsink, and that doesn't have any mass, it doesn't have any surface area. I have very little faith in that doing a good job of cooling the VRM. So yeah, I'm not sure how that's going to work out. But the good news is I actually now have acquired a case, so I can do thermal testing inside an actual computer case instead of just on a test bench and then telling you how putting a fan over the VRM actually fixes everything, which it does. Like, if you just point a fan at a VRM, everything is immediately fixed most of the time. So yeah, but basically VCore VRM itself, it's a solid VRM. I mean, this was the same VRM that Gigabyte had on the gaming K7, as well as the gaming 5 on X370. So yeah, though Ryzen 2000 does pull a bit more power, and that could be a problem. This should be fine. That heatsink is not this heatsink is not confidence inspiring though. So yeah, we'll see. Hopefully, like, you know, as long as it doesn't hit like over 100 degrees Celsius on the VRM, I'm gonna say it's fine, because it is. Because really the main temperature that's concerning is like the temperature these capacitors can take, which all of the capacitors on this board, like all the aluminum polymers around the board in the cans, those are APAC, which is an ASUS favorite capacitor manufacturer for cheaper motherboards. They're a Taiwanese company, and these are all of 5,000 hours at 105 Celsius. So yeah. These are bog standard ASUS capacitors. If you don't have a high-end board, this is probably what you get. Gigabyte is the same thing, actually. And I think even ASRock uses these. So these are really, really common, and like, you don't hear about boards dying with them left, right, and center, but then like they are only rated to survive 5,000 hours at 105. So if the VRM gets hot and you have the VRM running hot for a long amount of time, you know, that's a problem. But hopefully that heatsink actually does its job. Probably, hopefully. Anyway, let's get on to the SoC VRM, which I think is kind of misplaced on this board. Because it is a 4-phase, so you do get one, you know, the 1, 2, 3 power stages and the doubling scheme. So essentially it's a 4-phase. And, well, it does mean that, you know, for sort of your two categories of, like, say, 1.2 volts for a desktop CPU and 20 to 30 amps current output for the SoC, you're going to be looking at like 3.6 to 4 watts, which is fine. And if you're on an APU, which you might be pushing like 1.2 to 1.3 volts and about 40 to 60 amps, I'm not yet sure. I have received an APU recently. I will be testing. How much power those pull pretty soon, but haven't done that yet. 40 to 60 amps, you'd be looking at about nope, misreading my notes, 4.8 to 6.8 watts. So, you know, that's a really solid SoC VRM. The thing is, this is an ATX motherboard, and I'm not really like, to me, it doesn't really make sense to stick an APU in a full ATX motherboard. If ASUS went and just like scrapped this bottom half of the board, I would say it would make perfect sense to me. But I don't think, and also like this is a $180 board. Like that's the other thing. Like this is a $180 board. Who's gonna buy a $180 board to stick a $180? Well, like the APU is like 150 or something. So like, who's gonna buy a board that costs as much as their CPU or more? Because the 2200G is actually like significantly cheaper than this board, and the 2400G is just about the same price as this board. Like this doesn't really make a lot of sense because, well, like it's just really imbalanced as far as I'm concerned. Like if at least it was like MATX, so you could argue that it's for like a small form factor build or something. But no, this is a full-size ATX board with a 4-phase SoC for, you know, APUs that cost less than the board does. Like, I don't think there's that many people that would, like, do that. Or at least, if anybody is doing that, that sounds like a terrible way to spend money. Like, just really, like, yeah, it just doesn't make a lot of sense. So, yeah, it is a solid SoC VRM, it's just on the wrong motherboard. And honestly, I would say it would have been better if ASUS just, you know, scrapped that, ran the, instead, like what they should have done, in my opinion, is they should have not run this scheme. They should have run a 4x2 plus 2 for the SoC, right? And that would be your V-core there. And basically, you'd get these two phases up here as part of your V-core VRM. That, in my opinion, would make a lot more sense because the probability, like, who would stick a freaking APU in a $180 board? I have no idea what the thought process here is. Like, and this board isn't even, like, good for messing around with when overclocking, because, again, it lacks all the troubleshooting features. So, like, when I got this, I was like, ooh, this will be fun for messing with an APU on, because I'll have a strong SoC VRM, and then I got the board out of the box, and I'm like, wait a minute, there's zero postcode, there's no postcode, there's no LEDs, there's nothing. It's like, yeah, that's gonna suck. It's gonna really suck. So, yeah, just an odd decision as far as I'm concerned. Because the other thing is, on, like, other boards, like, yeah, it just doesn't really make a lot of sense. But still, if you do want to run an APU on this, the SoC VRM on this board is probably one of the best you can get, at least under $200. If you go past $200, there is the X470-F Strix board, and that has a stronger SoC VRM than this does, which makes even less sense if you think about it. Like, that really makes even less sense. So, yeah, that's great, isn't it? Anyway, let's take a look at the memory power. So this powers your memory sticks, and that would probably, like, I don't know what that's actually controlled by. It's a single phase. You have two high side FETs, two low side FETs. The FETs are the ever so popular 4C10N from On Semiconductor. These are, well, these are a perfectly good MOSFET for low power applications, like powering your memory. So yeah, these are a good fit here. So 1.5 volts, 6 amps output. You're going to be looking at about 0.7 watts of heat, which means this is going to be perfectly fine running just completely passive. And that's assuming a switching frequency of 300 kilohertz and only 5 volts gate drive. So yeah, I don't know what chip is actually controlling this VRM. The chip's right around here, and I can't ID it because it's one of the, Like Asus has like these chip suppliers that they use for smaller VRMs that have like the most bizarre part numbers I've ever seen, and you just can't get them to like get picked up by datasheet search engines or like Google even. So yeah. Anyway, I think this video is getting kind of long at this point. 20 minutes for this board. Funny thing is, I did a previous take which was shorter than this, but now I can't remember how that worked out. Anyway, V-Core VRM, solid selection of parts, solid phase count, should be really solid for overclocking. Bad heatsink. Like that heatsink is really concerning as far as I'm like, it just looks really bad. I don't think it's going to do a good job. We'll see how it does when I actually test it. Capacitors are your bog standard ASUS. The SoC VRM is really nice, but on like the wrong form factor and wrong board. The memory VRM is the usual, it's fine. And in terms of troubleshooting features, there's nothing except the clear CMOS down there, and that's a jumper. So, yeah, it's just like, this board is kind of barren. Let's put it that way. Yeah, there's not a lot of functionality on here that I would want for overclocking. And if you just build a system and it just runs at stock and you just never touch it, then yeah, you're fine, probably. But if you like build a system, stick RAM in it with, say, AFR memory chips, enable XMP, and the board doesn't post, well, this board's going to be so helpful in that scenario, won't it? Because it won't tell you that the problem is the memory overclock. So, yeah, this is honestly, for $180, I find this thing very disappointing. That's the only thing I can say. It's just very, very disappointing. Because like the VRMs are solid, but then there's like nothing, like the troubleshooting stuff I think is like, that really should be there. And then the heat sinks are like, they don't look good. So, yeah. Also, one thing I forgot to point out, this is one of the boards that does the sensible thing on X470 and has only an 8-pin, because there's a bunch of other boards which add a 4-pin for no good reason. Incidentally, you can stick a 4-pin CPU connector into an 8-pin connector, because this connector is, I think, mirrored. Like, the 4-pin is literally, like, these are literally two 4-pins next to each other, so you can stick a 4-pin in that, and it's fine. But yeah, this board has a single 8-pin because your Ryzen CPU won't magically start pulling as much as a Skylake X10 core or 12 core or 14 core. Like, it won't pull that much power. It doesn't need any extra power connectors. So yeah, that's it for the board. Thank you for watching. Like, share, subscribe, leave a comment down below. If there's any questions you have, and what else is there? If you'd like to support what I do here with actually hardcore overclocking, then there's a Patreon, a PayPal, and there's shirts you can buy, and there's a link to all of that down in the description below. And I think that covers everything, so I'm just going to go and like press that stop button.